All right, everyone, welcome. Welcome to the AFWERX Fusion panel. Today, we're going to be talking about advances in cybersecurity.
Yeah, I'm David Gotrik. I'm the chief cryptographer here at AgilePQ. I'm living here in Salt Lake City, Utah.
I'm Ulrich Lang. I'm CEO and founder of Object Security. We're in San Diego, California, focusing on cybersecurity automation. Glad to be here. Hi, everyone.
All right, wonderful. And then Mark.
Yes, hi, I'm Mark Sinckovich. I'm the federal manager for Digital.ai. It was formerly called ArcSan, and I focus on cybersecurity on the DevSecOps piece that we actually offer to customers. So thank you.
All right, wonderful. Okay, so what we're going to throw out are a couple of questions. So what we would like to hear from each of you from your perspective, and what are the main security challenges and trends for the coming 6 months, 1 year, 5 years, including tech trends such as AI, 5G, quantum, crypto, zero trust, or anything else you'd like to talk to about that. Give me your 60-second thought on that, please, David.
All right. Well, in the near term, in the next 6 months to a year, the post-quantum crypto candidates are kind of starting to come to fruition. So we'll see those kind of being tested out in the real world a little bit, and some of the, I think, industry leaders will start to cut over and start to use those technologies. Because in the a little bit longer term, 5-10 years, quantum computers are expected to be a little bit more powerful and expected to be capable of breaking a lot of the crypto we're using today. And along with 5G, there's quite a few security challenges still there in terms of securing a lot of the IoT side of things, as well as offering very high-speed cryptography to secure the high-speed links for automotive and such.
All right, perfect. And Mark, do you want to take a stab? Add on to that?
Yeah, absolutely. You know, where I'm sitting with software development and security, I believe that the most important thing that we're going to be needing to pay attention to is application security. There was a Forrester report that just came out back in May of this year that talked about application security as the #1 threat vector that companies or agencies are needing to guard against, and they're not really guarding against that right now as well as they should. As a matter of fact, what I've determined is that there's about 100,000 applications that are in use in the DoD today, and the vast majority of them are not protected. So they actually have a potential for cyber risk or you know, reverse engineering or hacking and that sort of thing. So I see that as a massive issue. And as you know, in the government, 100,000 applications will need to be probably either revamped or rewritten, and that's going to take a decade or more. So that's my answer there. From a 5G perspective, you know, we're focused on software development and also on the application security. So the speed of the network is not that important from our perspective. It's all about securing the applications.
Thank you. Ulrich, anything to add to that?
Yeah, I think so application security plays a big role. I think we're looking at, I mean, that's today already and might never get fixed, frankly, because, you know, it's just too expensive. It's just, eventually you retire technology, hopefully, you know. I mean, it's just one of those conundrums in cybersecurity that it's bolted on as an afterthought usually. And now with the advent of industrial IoT and so on, all these devices that were never designed for security are now being interconnected. So you do have this this problem. I think there's also a problem just with embedded, which people have not really looked at enough, where we're seeing that devices are very powerful. Like basically, it's cheaper nowadays in many cases to take a general purpose computer and put it in a appliance compared to building a PLC specific to a washing machine or something, right? So you will have a lot of dormant functionality that hackers can exploit. You know, on the AI side, I think what we're going to see is anomaly detection, maybe not now, but maybe in the next couple of years, using it effectively. It's being used, but you know, benefits are a little not 100% sure always. And I think what we're also going to see a lot is for social engineering and things like that. So we see attackers using AI significantly, I would think. Zero trust is one that's kind of a buzzword that's been floating around the industry, old wine in new bottles, I guess, a little bit. It stands in many ways for fine-grained contextual access control, capabilities based, and so on. I think that's been on the radar for 20 years. I started working on this 20 years ago, and it's probably going to take another while before the, it's a big hurt, the cybersecurity community, before it shifts focus away from pure role-based access controls or just username login to something more dynamic. So there are many technology thrusts. Overall, I'm wondering whether attackers are progressing faster than defenders and leveraging those technologies better than defenders due to less red tape and so on. So I just wanted to throw that out.
Okay.
Leave it at that.
All right. I know we had one question, and Mark gave an answer. I want to throw it out to each of you. You've spoken about it a little bit, but what do you perceive to be the greatest gap in cybersecurity today, each of you? And Mark, I can let you. Why don't you say what you wrote on the Q&A?
Yeah, absolutely. Like I said earlier, I think the biggest gap right now in cybersecurity today is the application security gap, where you have mission critical applications, whether they're in a weapon system like in an F-35 jet, where an application's running in one of those systems there, or whether it's on a mobile device for an airman, or whether it's in a server. If those applications are not secured correctly, that's the number one attack vector that our adversaries are exploiting now. And we actually have a way to solve that issue by locking down and hardening the application. So I think that's something that I've talked to a lot of government end users and people in the federal systems integrator community. And I think that they understand more and more that this is a problem, but they haven't really thought about it as much as perhaps they should. There's a couple of reasons for that I see. One is that a lot of the cyber security requirements or the responsibilities across program boundaries. So there isn't really anybody who's following those across different programs as much as perhaps they should, especially in the Air Force weapon systems. So yeah, that's my answer would be application security, whether in the weapons systems or whether they're in mobile devices or in apps on servers, for example.
Okay. All right, David or Ulrich, you want to give a quick answer to that too as well?
Yeah, I think one of the biggest gaps has to do with the Internet of Things and a lot of the sensor systems that are being deployed. The assumption by a majority of people is that the communications are secure and that the identity is secure of those devices, but largely nobody is implementing encryption on a lot of these sensors, mostly because standards such as like your TLS and things are typically too heavy to run on a lot of these constrained radio links. So that leaves communication in the clear, and that means that the integrity of that communication is not guaranteed. And that will allow an attacker maybe to send false alarms. It can allow an attacker to manipulate a firmware over-the-air update. It could then lead into a larger network breach. So I think the IoT and sensor communication links being secure, that's kind of a major security gap that's not being addressed right now.
All right.
Right. Yeah, I would agree with that. I think in fact, I agree with both what has been said so far. I think another one to add on is that there is probably still a process and skill issue in the cybersecurity community or in the community that would have the money to make stuff happen. So we're doing stuff that the cybersecurity community has lamented for the last 30 years or 40 years, I guess, that security is always bolted on afterwards and then never really quite works. So we do have that. Secure development lifecycle is kind of a nice thing, but we also, when we come to application security, or I guess any kind of security, I think these non-standard systems are a little hard it's a little hard to determine vulnerabilities in the first place. So we're doing an SBIR with Navy right now on that for embedded systems, and it turns out that much of the code vulnerability analysis that's out there is actually more for normal desktop server type environments, you know. But for embedded systems, it's actually already very hard in the first place to figure out what vulnerabilities do you even have? Where are they? How many do you have? Which systems are the low-hanging fruits to fixing, right? So that's really, I think, one of the big challenges there. I guess that goes in with what David said, that the ecosystem, the underlying ecosystem is changing rapidly. And, you know, you do have thin edge computing, thick, I guess, I don't know what you call it these days, edge computing, where you do more than a server was doing 5 years ago. You know, doing a bunch of AI, for example, in a small IoT device that itself is so powerful that it can be weaponized, you know, or subverted real quick. So we do have an ecosystem that's just so rapidly evolving, and security is very challenged to apply existing processes to that. From the very small systems to the very large power grids and so on. I mean, we're struggling all over the place.
All right, so I'm going to go through, we've got a few questions. So I'm going to go through a couple of them. If one of you wants to take one, you think it's appropriate. This is a COVID related question from Shane. As COVID has forced separation within the workplace and more people have moved from work from home, what challenges do you see with dissemination of higher classified information outside of secure workplaces?
I mean, I can take that from my perspective, if you'd like.
Sure.
This is Mark. Yeah, so I think what Shane is asking is if people have to work from home, can they work on classified information outside of a SCIF? I honestly, based on what I know of some of these types of environments, I've been in some of these environments, I don't think that's going to happen. I mean, the most important thing that you have to be able to do is to secure who gets access to the classified information and when they get access to it. And if you're actually allowing people to access this kind of information outside of a SCIF from a home device, then it's basically anything goes, and that's unacceptable to the vast majority of people that I know in these kinds of programs. These are programs that have need to know type basis, and you have to have, you know, all your electronics that are outside of, you know, like on the unclassified side have to be left at the front door in a locker, for example. So I think that basically what's going to happen is, even if people are going to stay home for a while and work from home, that people that work on classified systems are going to have to still go into the office and go into their SCIFs.
Yeah. And additionally to that, there's kind of a new paradigm being introduced with distributed sensor systems and distributed systems in general, with the way computers and the way some of the military is approaching this is that some devices are being left out in the field to maybe gather intelligence or monitor things, and some of that intelligence is classified. So that's kind of a similar case where you're going to have these devices that you don't really have full control over because they might be walked off with, or they might be compromised in the field. So I think leveraging more encryption technologies, there's a lot of newer encryption paradigms being introduced, like homomorphic encryption, where you're allowed to operate on encrypted data and things like that. And leveraging those a little bit more, I think will enable a distributed workforce a lot better.
Okay. Ulrich, do you have anything to add, or you want to move on to another question?
No, this covered it pretty much. I think it depends on the clearance level or level of classification, of course. Here, I think that needs to be said. That I guess as soon as it goes high enough, it's got to be how Mark said. There's no other way, because, you know, you could be videotaping your screen or something. You know, yeah. There's just a limit to. Cybersecurity can't solve every problem in the world, right? There's a physical security aspect to it that needs to be covered.
Yeah. All right, so here's an interesting question on skills. So Sherry's asked for skill issues, training or upskilling. So take someone who aspires to get an education and train them within your environment, or upskill someone who is already employed by your company. Which is the better ROI?
I can quickly answer something there. I think generally it is much easier to take an engineer who has the right mindset and make them a manager if they have that talent, I guess, than the other way around. So if you're looking at cybersecurity, which really, if you boil down below the CISO level, it's very technical. you have to understand the technicalities before you can really fully grasp it. If somebody's very technical, then you can probably train them towards cybersecurity, but it's just a big field. I think taking like how it's been in the past, where the chief environmental officer, they don't have the post anymore, and they make them chief security officer because somebody had to do it. You know, those days are over. So I think there's a lot of skill involved, and generally I would think it's better to hire than to train, because you know it takes probably about 20 years for somebody in this field to really understand what's going on. It's very complex, all of this. That's just my take on it.
All right. So here's a question from, I think the initials are PB. Do you see virtualization technology, container type architectures helping to lock down some of the application problems?
I can take this. This is Mark. So we see this right now with some of our software that we actually offer to the military or the government, in the fact that, you know, the waterfall type of software development, which is the traditional types that the government has used in the past, takes a long time. It's extremely complex, versus agile, right, which is more like modular based. And certainly if you have an increase in the security protocols of the software developers, you're going to get better quality software, but it's always a balancing act between how much time you have in your period of performance to complete the software development versus how much time you can actually put in the security protocols. Even if you had unlimited amount of time using kind of a sort of a best case scenario, and you delivered software, let's say in a couple of years to a customer in the military, the application still is not secure. It's going to be able to be compromised in a hacking type of a way. The code is not going to be obfuscated. So, you know, I see, back to that question, I see that the containerization is going to increase the time, decrease the time that it takes software to be developed, certainly. But you still need to have that security piece to be inserted right before production.
Yeah, I would like maybe add to that encapsulation, the way obviously virtual machines and containers and so on offer, can be used very effectively for increasing security. Can even be used for I guess, if you will, wrapping a security layer around an insecure application. So that is definitely possible. I think when you're looking at a web front end, for example, for an insecure application, you would be able to kind of proxy it through another front end and containerize the entire application so that you know which ports are open and so on. That's just a simple example, right? But it is possible to kind of contain the damage. That's not a permanent solution, and clearly isn't going to work for physically deployed kind of fielded tactical type in theater systems where people get their hand on the systems. But for anything that sits on a network, you know, server or something, it can be a quick way out of this problem, because you'll not be able to fix every application that the DoD has deployed over the last 30 years.
Right. All right, so we have about 4 minutes left. I just want to make sure there's one quick question, or what I think might be a quick question, and then a more overarching longer term question that might take a little longer. So Ron Ogan asks, how do we secure telemetry links and cloud assets, our virtual servers?
Yeah, so for the telemetry links, really what we need is a good identity on those sources of the telemetry. And then you need a good end-to-end encryption, because a lot of that telemetry might pass through untrusted networks. So really giving it a good identity so that new devices aren't introduced or spoof devices aren't sending bad telemetry, as well as ensuring the integrity of that data as it gets into the cloud. I think those are two of the most important parts.
Yeah. So one thing we add to this is also that so we're doing another project right now where we're analyzing, using machine learning to analyze the kind of pattern of the data. So you can, if it's a sensor, for example, that records a physical phenomenon of some sort, you can potentially detect cybersecurity attacks on the sensor or the data from a machine learning model. So there are additional emerging technologies that doesn't reduce the need for the crypto on the link and the hardened sensor or whatever it is. But there are interesting new upcoming ways. I mean, none of these are the silver bullet. In fact, that's one of the problems in cybersecurity, that nothing is the silver bullet, but it's just the more you layer on, hopefully the more secure you get.
Yeah. All right, so last question. Where is the opportunity to be proactive instead of reactive when facing the advancements of adversaries in cyberspace? And specifically, attendee asked about, geopolitical rivals like China that are investing advanced technologies like AI and quantum. So what do we need to be doing to counterbalance those actions?
I can take this to start. This is Mark. We have a product called Threat Analytics. When you deploy that with the ArcSAN application protection products that we have, it actually gives you predictive intelligence. So for example, let me give you a quick idea of this. So let's say Air Force has a financial application for their airmen that can be downloaded to specific airmen on their own mobile devices. If you deploy that application and you protect it with ArcSAN, it's going to make sure that that application cannot be reverse engineered. And even if the mobile phone gets jailbroken, you could still actually do your financial transaction and it would not be compromised. Furthermore, with the threat analytics piece, which is going back to this question, I would be able to then know who was trying to maybe do a put a debugger in there or some sort of a cyber incident or a threat, and I would have that information sent back to my server. It would be on premises at, let's say, an Air Force command that would allow me to understand where the threat's coming from with analytics showing me geolocation, showing me where around the world it's coming from, and then be able to then, when we go back and update that software application to the next revision, we could then add that information that we learned from threat analytics to make that application a lot more secure. So certainly that's one way to do it.
All right, final thoughts from David and Ulrich, please.
Yeah, I think taking the cybersecurity threat more seriously and really putting the responsibility on the vendors and everybody that's providing this technology, because a lot of the times cybersecurity is an afterthought, and it's something that we should probably do tomorrow. And it's kind of like, yeah, there's a tornado coming. Let's not, like, people kind of get into a comfort zone, and that's kind of like with the quantum computers, putting post-quantum crypto in as soon as you can will kind of prevent that day when that comes online and breaks current encryption, because then all your communications from that day and for the last 25 years, that'll all be out in the open. So that'll be a major event.
Right.
All right, Ulrich, final thoughts, please. We got to wrap it up.
Right. So I think people need to look more at their supply chain, not just for their toilet paper, but for cybersecurity. So software, bill of materials. On the hardware side, we've seen a lot. We've been working on this with Navy for several years, and there are many challenges there. And I think you gotta think that if people try to protect their environments, they're already sitting on top of a hardware platform that they had little control over, and on top of millions of lines of often open source code that they also didn't really check and have no idea what it does. So you're sort of building your security and your entire application on sand a little bit. I think that's a very underserved field. People really need to focus on that more, get clearer understanding. It's a global supply chain. China was mentioned. I don't really want to finger point anyone, but obviously most of our hardware components come from Asia. We don't really produce much ourselves there. And software, you're looking at the average software, would say probably like 80% of the components or 50% of the components are not from the US. Right. So there's a lot of potential for anything to go wrong,
Okay. All right, well, thank you very much. We're out of time. The programming has started back on the main AFWERX Fusion website.
Thank you.
Thank you. Bye-bye.
Thank you.
Bye.
Thank you, everyone.